Zoomचा व्हिडिओ
Yeah, it is visible, ma'am.
Yeah, okay. Thank you. So now the screen is visible to you?
Yes, ma'am. Yes.
Yeah, okay. Okay, thank you so much here. See here, dear friends, now our topic is especially your geometrical optics. And that's why, as far as that of here, this topic is concerned, the outline feature of this topic is your, see here, in the next slide, I have given you the idea about the same. What is the outline of this particular topic? As per your course, core course compulsory paper number 4 and section A, and I think that this is of your paper number 8 here. So the title of this paper is your optics and lasers, and this is our first unit in this paper, and that is nothing but your geometrical optics. So in general, whenever we have to consider the cardinal points of an optical system, related to that of here, the feature of this optics course is your, then afterward we have to focus on your coaxial lens systems, obviously considering with respect to the equivalent focal length and cardinal points are there. And then here we have to focus on the another topic, and that is nothing but your the hygiene's eyepiece. There are two types of eyepieces are in general. The first one is your hygiene's eyepiece, and the second one is your the Ramsaden's eyepiece. And related to this is your the what are the important cardinal points are here. So especially whenever we continue this topic is your, then obviously there are so many interesting things before directly approaching towards these particular units are here. What are those subjects are here? See people that here whenever we have to see the introductory part about this particular topic is your, what is this optics? What do you mean by the optics? So especially it is a very well-known branch in our physical science there, and actually it is the science of light is. So one of the most important field of physics, and yes sir. Yes, whether it is visible
Any
now?
issue?
Yeah, certain
Yes, ma'am, it is
technical
visible.
problem arises. Now it is visible, sir? Yeah, okay. So sorry, sir, for the interruption. So whenever we have to consider what do you mean by the light is your, then it is a type of energy. Yes, sir. Now whether am I audible and visible? Yes.
Yes, ma'am. You are audible and visible.
Okay, thank you, sir. What is light is your? So light is nothing but it's a type of energy, and it is electromagnetic radiation with a certain portion of the electromagnetic spectrum is your. And so obviously whenever we use the word which refers to the visible light, then naturally obviously particular type of the human eye, whenever we have to see, the human eye is responsible for the sense of sight as well. And what is the visible light, which is usually defined as having wavelength between the range of 400 to 700 nanometers is your, and between the infrared with longer wavelength and the ultraviolet obviously with the shorter wavelength is your. And when we come across for finding out such a sense of the light is your, then basically what are the important basics of your light. So how does light travel and how straight? So the answer to this question is very simple. That is, it travels very fast, and obviously it is a straight linear propagation is your. So the speed of the light is, basically it is 3 lakh kilometers per second, which is perfectly straight until something bends it. And hence, naturally, the straight paths of light are called as the light. There are 3 basic ways to control the light as well. Sometimes, whenever we have to block it with something, right, this makes a shadow. Whenever the 2 other phenomena of light, which are very important, either it reflected, that is, it changes its path with a mirror, or sometimes it bends it, that is, converge or diverge with the lenses here. It depends upon the type of the lenses and or the mirrors we have used here, whether the type is of your converging and or your the diverging is one. Now basically what is light is there, because generally optics which deals with the study of lights, and that's why the particular light energy, which are nothing but the optical radiations are there. So it's a type of the energy, and light is electromagnetic radiation with a certain form of the electromagnetic spectrum is your. And hence the word usually refers to that of here the visible light, obviously with the help of the human eye, and which is responsible for the sense of this light as well. Basically whenever we come across for finding out the spectrum, as it's having the range of 400 to 700 nanometers is there, and between the infrared with longer wavelengths and the ultraviolet with that of here the shorter wavelengths is well. Now whenever we have to see here, dear students, it is a very special branch of physical science, and that is nothing but the spectroscopy. So obviously it is very important whenever we come across for finding out the actual different characterization of the particular materials and or the particles are there. And whenever we have to study the other physical branches are here, especially these radiations which are very important. And this slide particularly gives you the idea about that of here these ranges, and that means the optical radiations are here. So basically it lies between X-rays and your microwaves are here. And what is the wavelength range? It is near about from 200 nanometer to 10,000 nanometer, and it gets divided into 7 bands are there. You people are must familiar with respect to these particular optical radiations are there. always we come across for finding out such a nice spectroscopy branch, and which deals with the study of the fantastic objects are here. And that's why it is very important that you must know about such a particular type of these bands are there. Right from your UV, then obviously that of here these bands are there. Whenever we have to consider that of here this A, B, C, and then visible light, similarly that of here infrared, for infrared regions are there, and hence naturally here we come across for finding out these typical branches are there. So these are the particular band spectra that gives you the idea about the whole particular type of the light rays are here, and what are their particular frequencies and or the wavelengths are there, whether it is in Armstrong unit or whether it is in case of here the nanometer range is here. So this is also deals with the study of your optical radiations are there. Now, whenever we have to focus in general on our main topic, and that is nothing but what are the three important main branches of this particular optics is your. So especially the first one is your the physical optics, obviously, which includes your wave optics. Light is considered as an electromagnetic wave is your. Then second thing is your geometrical optics. That is, it includes your ray optics, and which is having the particular path provided by that of here the light rays. Whenever we have to concern the trajectory of these light rays are here. So obviously this is always travel in straight lines. And the third main important is your also the quantum optics is your. In this case, we have considered your type of photon optics, and here basically light possesses your dual nature. Sometimes it acts as a wave, or sometimes it behaves as a corpuscular in nature, that is particle in nature. So obviously, basically it is a very, again, very beautiful topic and having a very large significance in case of this quantum mechanics are there, and that's why it is your the quantum optics. So these are the typical branches of your optics are here. Today we have to focus on that of here this geometrical optics, which includes your ray optics, and here light is considered in case of your the straight lines is your. Now, when we come across for finding out the introductory part about that of here the geometrical optics, basically it is also a ray optics, which obviously describes the propagation of light in terms of rays are here, and here which travel in straight lines, and whose paths are governed under by that of here the reflection and refraction at the interfaces between your different media. Now, whenever we have to summarize these laws are there, how we can summarize these particular laws here? So one by one, the first one is where when a ray of light hits the boundary between two transparent media, it gets divided into a reflected and a refracted ray. So as I already predicted you, the two important phenomena of these light rays are there. That is nothing but whenever it gives you the reflection and that of here the reflection, either with the help of the diverging and converging, depending upon the type of lenses are you. So obviously this is the particular theme. The second one is where it deals with the formation of images by using optical devices are there. The second thing in geometrical optics is here, that is sometimes the image get formed here, but at the same time we have to use the different optical devices are there. What are those optical devices? Just like that of here the prism and or the grating element and or certain kinds of the lenses are there, and so on. So obviously whenever we have to consider, this is one such particular basic law when we have to consider the actual ray optics, and whenever we have to study the actual propagation of light in terms of the rays are here. So whenever we have to consider, for example, the before transistor were invented, circuits used here which are fragile, large in size, heavy, and generate large quantities of large amount of power is given. So a ray of light is an extremely narrow beam of light is given, and all visible objects which emit or reflect light rays in all directions are given. Now we know that basically our eyes also detect light rays. So we think we see objects here, we really see images here, and whenever light travels from in a particular straight line is your, obviously we can see the image in the same spot as an object is your, and the light from that of here the object which reflects off and converges to form an image is your. What are the different terminologies over here? The picture shows you the idea about the same. When we have to consider the center particularly, see here, that is nothing but the center of that of here this feature. Whenever we can have an idea about that of here this optical illusion is your, the center here which focuses to particularly of this curvature. See here, the ray optics in this case, the principal idea behind that of here, this ray optics that can be shown in this particular schematic is one. See that particular center of the curvature, which is denoted by the symbolic representation A of that of here the sphere, which is the mirror is a section is one. What is the principal axis? You know, basically certain kinds of the terminologies which are very important while we are considering the actual idea behind that of here this particular principal axis is one. So what is this principal axis? That is line that passes through the center of this curvature. See, this is the line which passes through the center of the curvature is one and the center of the mirror. So the principal axis is perpendicular to the surface of this mirror at point A. And whenever we have to consider the center of the curvature C, which is the center of this sphere of which the mirror is a section. And what is CA is there? CA is the radius of the sphere, or it is also known as the radius of the curvature of this mirror, right? So what is that of here, the radius of curvature? It is shown by your letter symbol capital R is your, as per as that of here the schematic is concerned. The point at which the rays converge, see here, the point at which the rays converge is called as your the focal point, right? So depending upon the type of the lenses and or the mirror, whenever we have to consider whether it is of here the convex type and or your the concave lens and or the mirror are there, the focal points also get shifted. You know, basically it is a very basic thing, but as per this schematic is concerned, whenever we have to find out the point at which the rays converge, it is called as the focal point. And what is the halfway between C and A? That is the focal point of the mirror, and as shown in this figure, it is your F. What is this focal point? This is the point where rays are parallel to the principal axis, right? Principal axis means what here? Which passes through the center of the particular curvature of this, as I considered here, mirror. So obviously center of the mirror. And what is the most important feature of this principal axis is your, that is obviously it is perpendicular to the surface of the mirror at A. And this is your the focal point. This is the point where the rays parallel to the actually the principal axis and which converge when reflected off the mirror is your. What is this length FA as shown in that of here the figure? It is the focal length. What is this focal length? It should be designated with the symbolic representation small f is your. And the focal length is, you know, basically, which is half of the radius of the sphere is your. So these are very important terminologies when we have to consider the actual idea behind that of here. These terms are here, and what are the important terms that basically we must know about the same sense. Whenever we have to find out the actual idea behind that of here, this particular type of the figures are here. And hence, any particular system that should be considered while we are using the idea behind that of here, this particular type of the terminologies which are related to the geometrical optics are here. Now, friends, the most important point here, that is especially when we come across for finding out the features of the next term is your, what are those particular terms that we are going to see here? What is the actual idea behind the first point as far as that of here the feature is concerned? What are the cardinal points of an optical system is your? You know, basically, in generally in 1841, Gauss showed that any number of that of here the coaxial lenses, right, can be treated as a single unit. And the lens maker's formula can be applied here to measure, you know, basically the lens maker formula that can be applied to measure the distances from two hypothetical parallel planes are here. And the points of that of here, the interaction of these planes with the axis are called as your the principal points, or it is also known as your the Gaussian points are here. See here, the points of interaction of these planes with the axis are called as your the principal or Gauss points are here. And hence, naturally, whenever we come across for finding out these features are here, what are the important points are here that can be used basically in the same sense. And see here, in general, there are 6 cardinal points are here. What are those here? 2 focal points, then 2 principal points, and then 2 nodal points are here. 2 focal points, amongst them, there are 2 special focal points are there. One is your the primary and the second one is your the secondary. Then again 2 principal points are there, obviously designated with the help of primary and then secondary. Also 2 nodal points are here, primary and that of here the secondary. So basically these points are defined following the tradition that light is always supposed to travel from left to right is your in any optical system. Just I have shown you the one such particular schematic of this diagram. See here, right from left to right is your, and hence obviously the cardinal points of an optical system in general, these are the very important 6 cardinal points are your, especially 2 focal points, 2 your principal points, and 2 nodal points are there. So generally, whenever we have to find out the optical system, in general, these are the most important 6 points are here. Now, the planes passing through these points and which are perpendicular to the principal axis, which are known as your the cardinal planes are here. And in general, whenever we can find the image of that particular type of any object, without making a detailed study of the passage of the rays are here. And generally, whenever we have to consider this passage of the ray through the system by using such a particular cardinal points are here. So one by one, we have to consider these points are here. And actual, what is the significance of these cardinal points are here? Especially when we come across for the finding out or knowing the location of cardinal points, we can find out various information about the image of an object, which can be produced by an optical system as well. That is the information about the size and or the location of an image as well. Now, one by one, we have to concentrate on these points are your. The first one is your the focal point. That is, what are focal points are here. So obviously, these are the points which are basically lies on the optical axis are there. What are the basic features are here? Always the light rays comes towards this particular optical axis, as I already given you the idea from left to right is your, that arrive parallel to the optical axis are there, and that should be brought to a common focus after refraction. And hence naturally these are the points which are the focal points are here. What are primary focal points are there? As I given you the idea about the same, that is nothing but there are in general 2 points are there, focal points, but amongst them again primary and secondary. So the primary focal points are nothing but what are those here? That is, whenever the ray diverging from this point for a system with a positive power, or it is also you are the converging to this point with that particular system and having this negative power with refraction, then directly it will emerge parallel to the optical axis after refraction is your. Secondary point is same also as far as that of here, this point is your. Now, whenever we have to consider the first figure, these are the set of the rays. Whenever we have to find out, the 2 points are there, F1 and F2, which are nothing but your the focal points are here. And whenever the planes passing through the focal points and which are perpendicular to the axis, those are called as your the focal planes. Because when we consider a particular ray of the system which is incident on the system parallel to the axis, then after refraction, suppose it converges to the another point is your, and that is nothing but what is that point, which is the second focal point on the principal axis is your. And that's why now naturally this second focal point is known as your the second principal foci, or it is also known as your the second focal point. And for that of here the first, suppose now the rays starting from that of your point through F1 is your, and after refraction to that of your the system, it moves parallel to the particular optical axis and forming its image and infinity. Then obviously this is your the point, and that is nothing but your the first focal point is your. It is also known as your principal foci or first focal point is your. And these are the features of this particular figure. See here, as I already predicted to you, this is your the first focal point and this is your the second focal point. So focal points are a pair of points lying on the principal axis of the optical system and conjugate to the points at infinity here. So basically, this is a very important topic in case of geometrical optics, and that is nothing but the first one which is important. What are cardinal points are here, and especially what are the 6 cardinal points are here, as I already give you the idea about the same for finding out the theoretical aspects of these cardinal points are there. The next 2 points are which are very again important. Those are your the principal points and the principal planes are your. This figure also gives you the idea about that of here. These principal points are here. See, basically when we come across for finding out these principal points are here, what are the important basics related to this? These are the pair of the conjugate points here. See here, whenever we have to consider, these are the pair of these conjugate points are here on the principal axis here. This is a particular system which is having that of here the rays are there. See here, this is your the first principal plane H1P1, the second principal plane H2P2, the ray which is this is an incident ray, right, which was at that of here the first curvature at this point Q. Then it gets that of here the refracted. What is that particular path that should be traversed behind that of here this second? And whenever it converges at a particular point, due to that of here the presence of the second, then it is your the second focal point. Due to that of here first, whenever it emerges, suppose I extend this, then this is your the F1, and these are the particular planes H1 and H1P1 and the H2P2 is your. So these are the pair of the conjugates point on the principal axis. This is your the principal axis. So it is a pair of these conjugate points on the principal axis of the optical system, having your unit positive linear magnification is your. Now, whenever the plane we have to consider which is passing through H1, see here, this is the point H1. Whenever it passing through H1 and perpendicular to the axis, then it is called as your the first principal plane, right? This is your the first principal plane H1P1, right, of this lens is your. And what about that of here the second? That is nothing but the point of intersection of this plane, but with the axis, which is called as the first principal point. Principal axis is there, that's why it is your the first principal point, that is P1, and this is that of here the H2P2 is your, right? Now these 2 incident rays, that is of here PQ and F1S. See here, these are the 2 incident rays, that is of here PQ and that of here this F1s, which are directed towards this H1, right? These are directed towards this H1. And after refraction, appear to come from, see here, this seems to be appear to come from what is that of here, this H2, right? So H1 is the image of H2, and H1 and H2 are the conjugate points. That's why H1P1 is equal to what here? H2P2. And hence the linear magnification in this case, in case of such a particular optical system, is always equal to 1. So principal points are the pair of conjugate point on the principal axis of the optical system, having your unit positive linear magnification as well. Now the third one, which are the set of that of here the nodal points are here. So what are those nodal points and nodal planes are here? So obviously N1 and N2 are a pair of these conjugate points are here. So nodal points are the pair of conjugate points on the principal axis, right? Having unit positive angular magnification is there. And hence naturally, whenever we have to come across for finding out, these are the features of the particular unit positive angular magnification is your, then it is basically the N1 and N2. See in this figure, it can be shown you in that particular schematic. What is that N1 and N2? Which are nothing but the pair of these conjugate points are here. So obviously these nodal points are the pair of these conjugate points. And what is the second thing, dear student? You have to preferably note here, that is having unit positive angular magnification is your. And that's why now naturally we come across for finding out such a particular system, which should be considered here regarding the nodal points are here. And hence especially basically when we come across for finding out the features of that of here this cardinal, and what are the important features here that can be shown in this figure are there. What are those here? The principal points are there. Then obviously your the focal points are here. Then obviously that of your the nodal points are here. Obviously there are again two sub-themes are your. The one is that of here the primary one, and the second one is that of here the secondary one is your. Now, whenever we have to find out any image that should be constructed with the help of the cardinal points are here. Obviously, these are the features of that of here the particular image. Whenever we come across for finding out the settings of this cardinal point with respect to that of here the construction of the image, which corresponds to a certain one such particular object is given, which is placed on that of here the one such principal axis of the system is given. And basically we have an idea about that of here the same, as I have given you the idea behind the principal points and principal planes are here. So whenever we have to consider all these points are there, whether those are your the principal points, whether those are your the focal points, or whether those are your the particular feature of that of here the nodal points are here. So obviously there are these conjugate planes are here, and whenever we have to consider the particular incident rays, and then afterward which are passing through that of here the different principal planes are there, which corresponds to that of here this H1, then that of here the point H2. These are bifurcated from or extended towards that of here this way between this particular type of the object, and here it is the image is your. You know, basically here the object that should be shown with the help of this AB ring, and that should be the image form is your A1, B1 is your. So basically this is a very fantastic idea behind that of here this particular type of the cardinal points are here, and we have to construct an image using this cardinal point is here. Whenever we have to consider the nodal points, obviously then these are the points on the principal axis of the optical system is given, and where light rays without refraction which can intersect the optics axis is given, and hence the planes which are passing through the nodal points and perpendicular to that of here the principal axis are nothing but your the nodal planes are here. And whenever we have to find out the properties of these nodal planes are your, or the particular type of the nodal points are your, now you know that which are the pair of the conjugate points on the axis having unit positive angular magnification is your. So basically, you know that whenever we come across for finding out the actual expression in terms of the mathematical equations are there, how we can predict the ratio tan alpha 1 upon tan alpha 2 that is equal to, suppose say gamma, which represents the actual angular magnification is one, because it is the tangent of that of here this particular two planes which is behind the one such primary focus, and that of here the in front of that of here the secondary principal foci is one. Obviously this ratio tan alpha 1 upon tan alpha 2 always seems to be 1. So this is also a very nice idea behind that of here this particular construction of an image using the cardinal points. Now, whenever we come across for finding out the features of such a particular cardinal points are here, by using the different kinds of the lengths are here and their properties and the relations are here. So as I already given you the idea about in this figure, suppose here F1 and F2, which are to be the two principal foci is here. P1 and P2, which are the two principal points are there. And what are your N1 and N2? See here in this figure, it is shown that N1 and N2, which are the nodal points of the optical systems are here. So as shown in that of here, the figure, always whenever it is AB is a suppose a linear object is one. And whenever we have to consider in order to find out the image of this particular linear object of the point A, we make the particular construction in this figure. What are the construction are here? That is the ray AH1, right? That is drawn parallel to the axis, touching the first principal point at H1 is 1. So the ray AH1, which is drawn parallel, which is touching at this particular first principal point, right? At particular point is your H1 is 1. And the conjugate ray, what is that conjugate ray? Will proceed from your H2, a point on the second principal, right? So here the ray gets conjugated from this second principal point is your, and what is that second principal plane? H2P2, right? This is your H1P1 first plane. It is your H2P2 second plane is your. And hence, obviously, when we come across for finding out these are the features of these planes are here, then what is that here? The ray that should emerge from that of here, this H2, which is obviously conjugate point is 1. And then afterward, what is that? H1P1 is equal to H2P2 is 1. As we have stated here, the linear magnification always is equal to 1 is 1. What is the second term is your? Suppose the second ray that is of here AF2K2, right? So whenever we have to consider the second ray is your, what is that second ray? A, then it is F2 towards that of here this, right? So what is this particular ray AF1K1, ray AF1K1 and AF2K2 is. So say AF1K1 is your. Right? This is the first one. And hence, what is that here? The second ray. हा पहिला सांगितलं आपण, see here, and the second one is your AF1K1. So whenever the second ray AF1K1 is drawn passing through the first principal focus, right? That is of here F1 and touching the first principal plane, right? Touching the first principal plane at that of here this point. What is that point is your? That is nothing but K1. What is its conjugate ray? That conjugate ray will give the image of A, right? That conjugate ray which give the image of A is given. And hence naturally, what is the condition or at that point is your, that is your K1 P1 is equal to what here, K2 P2 is equal. And it will be parallel to the axis. So obviously this is the one such particular construction of image using the set of the cardinal points. And you know, basically the third also here as shown in the schematic, that is of here the third ray AT1 N1 is 1. And what is that AT1 N1? Is drawn, which is directed towards the first principle, directed towards the first nodal point is right. This is what the third, and this is your nodal point N1. And this ray passes after refraction. What is that here? Of any of the above two refracted rays are here. And those refracted rays obviously through N2 in a direction. Baga, इथे दाखवलेलं आहे तुम्हाला in the schematic it is through N2 is given, and through N2 it will be parallel to that of here this AN is given. And thus in this way the construction of the image can be formed out. We can use also the Newton's formula. Basically we know that the actual equivalent formula for that of here these lenses are here, and what are those particular features are here. As far as that of here the equation is concerned, that is equal to x1 x2 is equal to what here, f1 and f2 is equal. Whenever we have to combine the features of the combination of two thin lenses are there, when we come across for finding out the actual combination of two thin lenses are there, then basically the focal length of the system can be defined by the formula. You know that actually the particular relation between the image distance and that of here the object distance is 1. So 1 upon V minus 1 upon U is equal to 1 upon F is 1. And whenever we have to consider the features of the particular type of this image and obviously the object distance is 1, then naturally in this case we have to find out the focal length in terms of the particular heights at which this particular object, and then afterward the image that should be obtained. So obviously 1 upon F is equal to 1 upon F1 plus 1 upon F2 minus D upon F1 F2. What is that of here these particular features of the plane? That is nothing but it is the distance of separation between the combination of these two thin lenses are there. F1 be the first focal length, the second F2, and it is the combination of that of here. The total combined equivalent length is 1. And whenever we have to measure the power, then obviously you can use it in diopters are there. So these are the basic things when we come across for finding out the derivation for the same. As far as that of here, the first principal point, then the second principal point, and what are the features of that of here, the ideas behind the actual idea related to that of here, this cardinal points are there. In general, there are these 6 points as I already given you. Depending upon the features of the particular ray optics, very, very important, and what are the combination of that of here, the lenses using the features of the particular type of the construction of an image using that of here the cardinal points are here, right? Now whenever we come across for that of here the another topic which is again very important in this case, what is that of here is over the eyepiece. So am I audible, sir? Yes, can you hear me?
Yeah, ma'am, you are audible. Yes, yes, ma'am. Yes.
Okay, thank you. Now, what are the important point is your that is nothing but the what are the eyepieces are there. It is very, very important point in this geometrical optics, especially when we come across for finding out that of here the features of the geometrical optics are there, and what are the importance of these eyepieces are here. Generally, basically, this slide shows you the idea behind the same. When a single convex lens, right? when a single convex lens, as we have considered, it is nothing but the actual particular idea, which is considered as an eyepiece as well. The rays coming from the peripheral parts of the image of an object, right? Peripheral parts, which are the edge parts are here. So obviously these are the peripheral parts of an image, but which are coming from that of here the object, formed by that of here the object. Then they would cross over these eye lens. And what happens then? They fail to enter the eye, right? Which is very close to that of here this eye lens, right? And this reduces your field of view. So obviously, to overcome this defect, another lens is called as your field lens, is introduced between the objective and the eye lens. All right. So these are the very important feature of the eyepieces are there. See here, dear student, why we have to study these eyepieces are there. And especially when we come across for finding out the features of the geometrical optics are here, then obviously these are the two kinds of the eyepieces are here. One is that of here the Ramsden, and the second one is here the hygiene eyepiece. Before proceeding further toward these topics, for finding out the details about these eyepieces are here, you must know about why we considered here and why the field lens that should be introduced between the eye lens and that of here the objective is here. So whenever we have to consider a single convex lens and which is considered as an eyepiece is here, the rays coming from the peripheral parts, right? That is nothing but the other at the edge. What are the particular types of the rays which are coming? From that of here the peripheral parts of the image, but the image that should be formed obviously due to a certain object as well. And you know basically the particular object which is formed by that of here the object as well. And then the peripheral parts, the rays coming from that of here the peripheral parts of an image of an object formed by the object would cross over this eye lens, right? And then obviously it does not enter into the eye. Here the particular type of that of it, the reflection gets failed. That's why it failed to enter the eye, which is kept very close to the eye lens. And this reduces your field of view, our sight of view. And that's why what is the sense of sight is your. And that's why to overcome this difficulty here or this defect is your another lens which is known as the field lens that should be introduced between the eye lens and that of here the objective is your, right? What is the importance of that of here the objective lens is your? We know basically the magnification power of a simple microscope, right? You know there are varieties of microscopes are there. So the magnification of that power of a simple microscope can be increased by decreasing the focal length of the lens, right? But however, the focal length of a lens cannot be decreased beyond a certain limit. And that's why now naturally the lens of a small focal length has a smaller diameter because the curvature of the surface is very large and the field of view is very small. And that's why now naturally to increase the magnifying power, right? So to increase the magnifying power, what happens there? We have to use the particular two separate lenses, right? Two separate lenses are always used. One which is near the object, right? One which is near the object and which is obviously called as the objective, and the next which forms the real image, right? So obviously one which is near the object is called as the objective, which forms a real image of an object, right? And that's why now naturally when we consider the important features of these are the particular idea behind that of here these eyepieces are there. The one of the lens which is kept near to that of him. The second one which is used to enlarge, the second one which is used to enlarge this image viewed by the eye, and this is known as your the eyepiece. So it is known as your the eyepiece, and this is the defect, as I already given you the idea about this particular type of the lackings and the defect and the error here, which gets failed to enter into the eye, and that's why the necessity of this particular type of the piece is one. So we have to overcome this defect by keeping field lens between the eye lens and that of here the objective. And there are these particular two types of the objective eyepieces are there. One is your the Ramsden, and then one second one is your the hygiene eyepieces, right? One such basic thing behind also this particular aspect is your, that is the theory of eyepiece is your, what is that here? That is an optical instrument is required to produce a magnified image free from that of here the aberration. You know, basically there are certain kinds of aberrations are there. This is a very important topic, but you people then afterward will have to study towards the next chapters are there, towards your next prescribed units are there. So whenever the optical instrument which is required to produce a magnified image which is free from the aberration and a bright image covering a wide field of view is given, then obviously suppose a single lens is used as an eyepiece, the final image will suffer from the spherical and the chromatic type of aberrations are there, which arises due to different wavelengths of the light rays, obviously, which belongs to the different types of the color chromatic aberrations are here. What is the another drawback is your, whenever this, when we are considered in small field of UV is your, then which becomes very lesser and lesser as the magnification of the instrument gets increased, and hence obviously the rays passing through the outer portions of the image are refracted through the peripheral portions of the eye lens, and they cannot enter directly into the eye. Very small aperture of the pupil of our eyes, and obviously then it is very close to that of here the eye lens as shown in that of here this figure, and hence only that part of the image which is nearer to the axis will be seen, and therefore the final image will cover a very small field of view. So to increase this particular field of view and the magnifying power, an external lens can be introduced here. And what is that external lens? Can be introduced between objective and eye lens, and that external lens is nothing but the field lens. So this is also one of the most important brief idea behind it is it is very simple. You people must have to read entirely over it frequently, and then once you have got your concept gets clear, then it is very easy to understand the actual formation of this eyepieces are there. See, now there are this fantastic idea behind that of here these eyepieces are your, one is your hygiene eyepiece and the second one is your the Ramsden eyepiece. Now it is converging a beam enters in the field lens and form a virtual image before the eye lens is over. What are the basic idea behind that of here this eyepiece? We can see with the help of its merits and demerits are there. So obviously hygiene eyepiece is fully free from chromatic aberration because the distance between the lenses is equal to half the sum of their focal lengths. And what about that of here the particular feature is your the minimum spherical aberration because of the distance between the two lenses, which is equal to the difference of their focal lengths. The third one is where the field of view of this eyepiece is very small than that of here the Ramsden eyepiece. So when we come across for finding out hygiene eyepieces, generally one thing is that in an hygiene eyepiece, the converging beam enters the field lens and forms a virtual image before the eye lens is one. So it consists of again two lenses are there, having focal lengths in the ratio generally 3:1, and the distance between them is equal to the difference between their focal lengths is equal. So these are the constructional features of these Huygens eyepiece are there. Obviously, two lenses having the one such particular types of the focal lengths are here, and the eyepiece is free from that of here the chromatic as well as the spherical aberration, but actually sometimes it is due to the defective formation. That is, I have already predicted here minimum spherical aberration, because the distance between the two lenses is equal to the difference of their focal lengths. Aberration is nothing but the defects, drawbacks, errors, which is directly arising from in the image formations are there due to different kinds of the causes are there. One such is your the spherical one, due to that of your the curvature, radius of curvature, whatever may be the other features of these aberrations are here. Aberrations, it is a very separate topics in optics, and whenever you people will go through this, then you definitely understand the actual ideas behind these drawbacks and the defects which are known as the aberrations are here. Now, similarly, when we come across between the actual lens combination, which is formed in case of Huygens eyepiece, which is an achromatic combination or the system is over. So obviously the capital distance d between the two lenses can be considered that their particular half of the sum of the focal lengths are. So we especially derive the formula d is equal to f1 f2 divided by 2, where capital D is the distance between the lenses. Your f1 and f2 are the focal lengths. So this one is a very brief theory. As per your syllabus, what are the merits and demerits that I have to given you in this particular feature. So the one such important idea behind it is the particular one, first one is which is fully free from chromatic aberration. What is the reason? The distance between the lenses is equal to half the sum of their focal lengths. And what is of your minimum spherical aberration? Again the same. What is the distance is equal to the difference between their focal lengths area. And what is the field of view of this eyepiece, which is very smaller than that of here the another kind of the eyepiece, and that is of here the Ramsden's eyepiece is well. So again, in case of Ramsden's eyepiece, whenever we come across for finding out the actual theory behind it is then in this case of eyepiece, again, whenever we come across for finding out the settings of the cardinal points using the Huygens and then that of the Ramsden's eyepiece are here. Afterward, I shall give you the particular type of the notes or whatever may be the features if you people will require those aspects, because those are purely the mathematical terms are here. How we can find out the equivalent focal length and what are the features of this particular type of the settings of the cardinal points are here. Whenever you people go through any particular point related to our references are there and what are the textbooks are there, that I will predict here afterward, or I will give you the one such slide related to the same. Then you people can have an advantage for the same. You can use those particular terms are here because those are the basic particular theoretical aspects. Now, what is your Ramsden's eyepiece? See here, Ramsden's eyepiece consists of two plano-convex lenses are here, and each of focal length f separated by distance equal to 2/3 of f. Total focal length check. What is the particular multiples of this? 2/3. I mean 2/3 of its focal length is one, and the lenses are kept with their curved surface facing each other, and that's why now naturally whenever we have to consider the actual theoretical aspect and find out the derivation for the equivalent focal length, again by using the same formula, 1 upon f is equal to 1 upon f1 plus 1 upon f2 minus d upon f1 f2 is equal. So whenever we come across for finding out the features for the same, then here f is equal to 3f by 4. And hence naturally here whenever we come for finding out this total focal length is equal to 3 by 4th of this focal, then that particular equivalent length lies between the field length and that of here the eyepiece as well. So again, these are the mathematical equations. Whenever we have to consider the position of the crosswires are there in this case, then obviously the position of the crosswire in Ramsden's eyepiece, which is placed at the position of this focal length is one, and which is related to the particular field lengths that can be used here. Where you have to go through that of here the derivation, and we can see what are the in general the merits and that of here the demerits of these particular features are. What is the field of view of this eyepiece is fairly wide. It not entirely free from that of here the chromatic aberration, since the distance between the two lenses is not equal to half the sum of the focal lengths. As I already given the idea, f by 2 is u, right? Chromatic aberration also gets minimized by using the achromatic combination, both for the field lengths and the eye lengths. And what is the spherical aberration? That should get minimized here by using these two plano-convex lenses, right? As we have to use plano-convex means what here? The one of the plane is your, one of the surface is your plane and the another one is your the convex. That's why we have to use these plano-convex lenses. Obviously, it spreads the deviation over these four surfaces are there. Obviously, your Ramsden's eyepiece is used practically in all instruments here, where measurements of the size of the final image are to be made. Whenever we have to make the measurements, we can especially use the your Ramsden's eyepiece, right? Then what are the important features is your, it is also known as your the positive eyepiece, because here rear image is formed by the objective in front of the field lens, which further acts as a real object for the eye lens. That's why it is your the positive one. While in case of hygiene, it is that of here the negative one, right? Now, these are the important features of this particular type of objects. And what are the important comparative points? What is the differentiation points or distinguish between hygiene's eyepiece and that of here the Ramsden's eyepieces are there. Similarly, those points as I already given you, first part is where the image formed by the objective lies between field lens and eye lens. Here in Ramsden, it is formed by the objective in front of the field lens. Here no crosswires can be used. Here crosswires can be used. Condition for minimum spherical aberration and achromatism are satisfied. Here, those are not satisfied, but can be made achromatic by using achromatic doublet. We can't see it here, right? We have to minimize, but how? By using the particular achromatic doublet is different colors, chromatic, whatever it is not related to this, means obviously we have to use the single. The next point is your image form is slightly convex towards the eye, and hence the other aberrations are not completely eliminated. Here the image form is flat, and hence the other aberrations are completely eliminated. Next is your use in microscope and other optical instruments for qualitative observations only. It is the distance between the eye lens and the eye lens is greater, and hence lens strain to the eye. What is the next is your the distance between the eye lens and the eye too small, and hence more strain to the eye. Here the distance between eye lens and the eye is greater, and hence less strain to the eye. So depending upon the constructive features of these eyepieces are there, we can have an idea behind that of here this particular features of the eyepieces. So basically again there are different points are here. The eye clearance is 5% higher in case of hygiene eyepiece, while we are considering Ramsden's eyepiece, the eye clearance is too small and less comfortable. So obviously, whenever we have to consider the less strain, but as far as that of here, the eye relief and the clearance, that is very important is here. And also the other types of aberrations are also minimized in both of these eyepieces are there. The coma is absent and distortion is 5% less in Huygens eyepiece, but in case of other aberrations, the distortions are not eliminated here. So dear friends, here these are very important topics. I shall given you the idea about the same again in the same manner. What are the features of these eyepieces are here? In case of the geometrical optics, then that of here this particular type of the cardinal points are here. Then set of your principal points are here. Then set of your the particular features of the focal points are here, and then again that of here the idea behind that of here this idea related to that of your nodal points are there, and what are the kinds of that of your the eyepiece whenever we have to consider related to that of your the Huygens eyepiece and that of your the Ramsden's eyepiece are there. So whenever we come across for finding out the features of these eyepieces are here, then obviously these are the certain kinds of the references. See here the textbook is there, which is very important. Subramaniam, Brijlal and Avdundulu. S. Chan publication book is over. And there are so many reference books. Only especially I have mentioned here very few. Optics by Ghatak. Then textbook of light is over. But you people goes to that of your this Ghatak. Then obviously by that of your Jenkin and White. As far as your PG education is concerned, related to the different physical science branches. And hence naturally, this is a very first idea. And that is which is the very basic idea related to that of here, this geometrical optics is over. So thank you very much. Thanks a lot for your patience hearing. Once again, I would like to thank you, even though I am very grateful to respected Dr. Sawan sir, the coordinator of this program, respected Dr. Manish Deshpande sir, head department of physics, and your respected principal sir, all the organizing team and the management, and especially you dear students, you are there. So we are here. You will be there. So we are here. So obviously, it's a very nice opportunity. Once again, thanks a lot. Thank you very much. Yes.
Thank you very much, ma'am, for a nice presentation on geometrical optics. Even a person like a person like me, who is a zoologist, who understand this geometric optics. Usually, ma'am, we use the eyepiece in our microscope, and we know about only the that eye lenses, and we didn't actually know about the what is the principle behind that images we observe through the microscope. But today, by viewing your today's lecture, I understand that how the minute images are magnified through these optic lenses. So thank you very much, ma'am. I hope our student has got clear their point. Now I ask the student if they have any query, they can ask the resource person.
Yeah, definitely, sir. You are always welcome.
Dear student, if you have any queries over this topic, you can ask the ma'am.
Madam, namaskar.
Yes, sir.
जयश्री मॅडम.
या
मनीष देशपांडे बोलतो नांदेडहून.
हो नमस्ते सर. खूप थँक्यू व्हेरी मच. चांगला प्लॅटफॉर्म दिला सर तुम्ही.
कसं आहे, आपलाही कार्यक्रम घेतला होता आणि हे आमच्या मित्राचंच आहे आणि
करेक्ट.
आमच्या कार्यक्रमामध्ये तुम्ही फार छान लेक्चर दिलं होतं. आमचे भूपेश सर आहेत तिथे नेमानिवार. मी त्यांना म्हणालो की मी देतो एक कॅन्डिडेट, खूप छान बोलतात त्या. झालं मॅडम तुमचं लेक्चर एकदम.
तरी सर जरा
तरी माझ्या लेक्चर पुढे इंटरफेरन्स घेणार आहे. आवाज येतोय का?
हो येतोय सर, आता येतोय. हा
लेक्चर झाला, कारण नंतर मी इंटरफेरन्स घेणार आहे.
ओके.
बरं झालं ते तुम्ही सुरुवात केली याची.